So today let us discuss the properties of modular operators. Mostly we have there are four properties. The first one is A congruent to B more n if n divides A minus B. And second property is A more n is congruent to B more n. It implies A is congruent to B more n. A is congruent to B more n implies B is congruent to A more n. And the fourth property is A minus it should be A congruence. Okay, so I'll show you all the proofs for these four properties one by one. First, I'm just reading out these properties, so I'll prove all these things within 5 minutes. Okay, this is A congruence to B more n and B congruence to C more n. It implies A congruence to C more n. So let us see the proof for properties 1, that is A congruence to B more n if n divides A minus B. So see the proof here, given n divides n minus b. See these symbols, this is divide. Okay, so we read as divide. Okay, n divides a minus b. So by the definition of divisibility, there exists an integer k such that a minus b is equal to kn. So rearranging this equation, what we get here, so we can write a is equal to b plus kn. Like when we divide a dividend by a divisor, we get remainder. How do we get the dividend? So we write the dividend is like this, right? Suppose this is a dividend is and suppose let me consider dividend is a and divisor is n. So what do we do? This is n divides this, right? And we will get this remainder. So how do we express a? N into this quotient, n into q plus r, like that. Suppose we can consider this is a dividend, so b is remainder. So but a is actually, this is also remainder. Okay, I'll express this later. So b plus kn. Therefore the difference a minus b is a multiple of n. So by the definition of congruence modulo n, two integers are congruent modulo, and if that difference is divisible by, and this one I have already discussed in the first video of modular arithmetic. Okay, so hence a is congruent to b more n. Therefore if n divides a minus b, then a is congruent to b more n. So let me name this equation 1. So property 1 is already proved. For the property 2, for the proof of property 2, that is a more n is congruent to b more n. So from this a is congruent to b more n. This means that the remainder of a, what does this mean? This means that the remainder when a is divided by n is equal to the remainder when b is divided by n. So this means that is a more n is congruent to b more n. So we can write this. Okay, a is congruent to b more n. So this is the proof of this is the proof for property 2. And for the property 3, this a is congruent to b more n. We can write this, right? We can also write this, b is congruent to m more n. So there's no difference. Okay, so these are the proof for properties 1, 2 and 3. Now This is okay, this is for property 3 and this is for property 2. Now for the property 4, you see here, if A is congruent to B more n and B is congruent to C more n, then A is congruent to C more n. So these two are given. Suppose given A is congruent to B more n and B is congruent to C more n. So from this, A is congruent to B more n. That means n divides A minus B, right? We have all this since in the in above when we prove for property 1, right? So therefore, there exists an integer k such that A minus B is equal to Kn. Now again from this, B is congruent to C more n. From this, we can see it here, n divides B minus C. So therefore, there exists an integer m such that B minus C is equal to Mn. So adding these two equations, let me consider this is equation A and this is equation B. So adding these two equations, we are going to add so A and B. See, so A minus B plus B minus C is equal to Kn plus Mn. And so by simplifying, we will get so we have to cancel these two, but so we'll get A minus C is equal to K plus Mn. So since K plus M is an integer, that n divides A minus C, this K plus M is nothing but this is the multiples of n, right? So K plus M is the multiples of n, huh? So hence, by definition of congruence, A is congruent to C more, and therefore this is a proof. A is congruent to B more and B is congruent to C more, and then A is congruent to C more, and this is a proof for properties 4. So in next class, let us see some operation, modular arithmetic operation, and these are the proof. Okay, let's stop here for today's class.